All right, folks at home, we're going to talk about Lesson 8 today, and we're going to take this into equations for percentages. Honestly, I don't use equations that much to do a percent question, but I'll show you anyway. We have some choices when we do percents as to how we solve them. First question, our warm-up here, how do you get from one number to the next using multiplication or division? Here's what I want you to think about. How do I get from 100 through multiplication to get to 106? Well, let's see. I need to wipe out that 100, so I'm going to put it in the denominator of the fraction and then multiply by 106. Another way to say that is I could take that 100 and multiply it by 106 over 100, or as a decimal, that's 1.06. But we can think about these as fractions and wiping something out while putting in the other thing. So if I wanted to look at from 100 to 90, 100 times what gives me 90? Well, again, I want to wipe out that 100, multiply by the 90. Hundreds would cross out. Remember, that's 100 over 1, leaving me with 90. If I want to go from 90 to 100, 90 times some fraction gives me 100. I want to get rid of the 90 by dividing by it, and then multiply by the 100. Another way to say that, again, would be the same as multiplying by 100 over 90. You guys do the 106 to 100. So this lesson in your book assumes that you know how to find the percent of a given number, and that's not something we've talked too much about this year. There's lots of different ways that people teach finding percents. If you know a way to find a percent of a given number, feel free to use it. I'm going to show you just a quick method that I've developed in the last couple of years that my students seem to find really easy. So I'm going to show you what to do here. If you're given a question like this, find 20% of 32. Again, there's lots and lots of different ways, and we can talk about different ways of finding that 20% of 32. But here's what I find is easiest for me. Can you find 10% of a number? If you can find 10% or 1%, we can really find any percent. If I find 10% of 32, well, I do that really easily. The decimal in that 32 is right here, right? It's 32.0. If I want to find 10% of 32, all I need to do is move that decimal over one place. 10% of 32 is 3.2. Well, now, all of a sudden, it's really easy to find 20% of 32. 20% of 32 is just the 10% multiplied by 2. So if I multiply that 3.2 times 2, that's my 20%. 10% times 2 gives me 20%. 3.2 times 2 gives me 6.4. 20% of that 32 is 6.4. So if we can find 1% or 10%, we can find any percent in either in our heads or on a piece of paper. Let's try another one. Find 15% of 60. Well, again, I'm going to go by my basis of let me find 10%. 10% of 60. Again, remember the decimal in 60 is right there. I'm going to bump it over one place. 10% of 60 is 6. Well, how am I going to get to the 15 from the 10? Well, I can do this maybe this way. 15% is 10% plus another 5%. Well, 5% of 60 would be half of 10% of 60. So 5% of 60 would be 3. Now to find 15%, that's 10% plus 5% is 15%. The 10% was 6, the 5% was 3. If I add those up, I get 9. 15% of 60 is 9. Base it off of simple things to find, and you can find any percent. Find 7% of 500. Well, let's see. If I find 10% of 500, that doesn't help me much. 10% of 500, again, moving that decimal one place would be 50. That doesn't help me get to 7 much. But what if I found instead 1% of 500? 1% of 500 would be to take that decimal and move it twice, or move it one more place in that 10%. 1% of 500 is 5. To get to 7%, I would then multiply by 7. 1% times 7 is 7%. That 1% value, the 5 times 7, is 35. 7% of 500 is 35. So if we can find, again, 1%, 10%, we can find 8%. Find 23% of 250. Let's see, 23%. 10% would be, moving that decimal once, would be 25. 1% would be 2.5, moving the decimal one more place. So how do I go from 1% to 23%? I multiply by 23. 23% of 250. I'm going to multiply that 2.5 also by 23. That's my dog grumping in the background. And if I multiply there, I get, multiplying that out, I get 57.5. 23% of 250 is 57.5. So again, keep that in mind as we go through this lesson. There's a couple times here where we're asked to find percents, and we haven't really talked much about that this year. Nice and easy to do it this way. There's two problems here. They're kind of complicated, and I don't have a whole ton of time. This is making the video too long, so I want to go through just a couple of the sections of the first problem and see if you can finish it off and then do the second problem on your own. So we're talking about interest and depreciation. Interest is something where your money goes up, and depreciation is when the value of something goes down. So in question number 1, money in a particular savings account increases by about 6% after a year. How much money will be in the account after 1 year if the initial amount is $100? And then they give you different amounts as well. So you put money in the bank pays you a little bit to keep your money with them. So the question is, how much is in the account after a year if it increases by 6%? So for each of these values, what I want you to do is what I just showed you. Find 1% and then go from there to 6%. So if I take that first amount, the $100, well, 1% of 100 is 1. So 6% of 100 would be 6, which would mean after the first year, not that my account has $100 in it or $6 in it, but that it has the original amount plus $6 more, or $106. So I left a column in the middle there to kind of show you the computation. Now what we're going to do is we'll do the same thing for each of those different amounts. The next amount is, what if the account had $50 in it? Well, 1% of 50 is 0.5, so 6% of 50 would be 3. So after 1 year, I would have $50 plus another $3, so $53. See if you can continue that table. It does ask about X at the end. See if you can come up with a good expression there. And then try number 2, where they're talking about the car's value decreasing by, in this case, 15% after each year. See if you can work through that. That's not an easy problem. All right, these are not so easy to do on your own. I wish we were together and we could discuss, but we are not, so we'll do the best we can. We're looking for an equation that matches each of these situations. Now, there's only 2 of them, and they all involve either a 23 or a 77. Now, here's one of the things we know. If that number is over 1, it means an increase. If that number is under 1, it represents a decrease. So let's see what we can do here. The water level in a reservoir is now 52 meters. This was a 23% increase over the original. What was the original depth? Well, it's either going to be, because it's an increase, it's one of these 2 things. It's a 23% increase. That means it's this one. Second one, the snow is now 52 inches deep. If this was a 77% decrease, what was the initial depth? Well, for this one, we had the original snow amount. Let's call that X, and that's decreased down by 77%. So notice it doesn't say it's decreased to 77%. It's decreased by 77%, which means there's 23% of the original snowfall left. That's this one. Again, these are not easy concepts. We'll practice them. There's lots of ways to do these percents, though, so if you don't get it right away, do not worry. We're going to flash back in this activity to the question we had in the last lesson again, as Dad's was 12. That 12 divided into equal increments meant 50% would be 6 and 6, and if we add another 6, that would be 150%, or 18 gallons. 18 gallons. I believe the question is about the gas tank in Dad's car holds 12 gallons. The gas tank in Mom's truck holds 50% more than that. How much does this gas tank hold? And we talked about this. So the question here is, explain why this situation can be represented by 1.5 times 12 equals T. Well, the 1.5 is our 150%. Percent to decimal, decimal to percent, times the 12 was the initial amount, gives us the T, and the T would represent how much gas is in Mom's gas tank. Part 2 here, write an equation to represent each of the following situations. Now these, again, not easy. A movie theater decreased the size of its popcorn bags by 20%. The old bag held 15 cups. So if it decreased it by 20, we'd now be at 80%. 80% is a decimal. 0.80 times 15 gives us, I'll put C for cups of popcorn. After a 25% discount, the price of the t-shirt was $12. And then we have Part C. I want you to try that one on your own. Part C, compared to last year, the population of Boomtown has increased by 25%. The population is now 6,600. What was the population last year? Well, that would be 100, the whole percent plus 25%. Now in this one, we're going to multiply by the original population, gives us that 6,600. These are a little tricky. They're a little tricky to get used to. We will practice them, but again, lots of different ways to do percents. All right, we'll do a couple practice problems in the book, and that's it. Guys, have a good day.